Hello dear students, in this video let us start the p block elements, that is the first group of this p block, group 15 elements. So now let us see which are the elements that belongs to this group 15. So group 15, the first member of this is nitrogen. So nitrogen, phosphorus, arsenic, antimony and then the bismuth. Okay, so the first two elements, that is nitrogen and phosphorus, they are non-metals. Okay, these are the non-metals. The arsenic and the antimony, which are metalloids. The last member of this group element, that is bismuth, which is a metal. So what you can see here is the metallic characteristic of the group 15 element, no, that increases down the group. So as we move down here, the metallic characteristic for the group 15 element, it increases. So what is the main reason for this is, we'll study this. So what are metalloids? So the elements whose property which lies between the metals and the non-metals. So they are not completely metals and not completely non-metals. In between they are, so they are called as metalloids. So remember this. Next is occurrence. So there are many of the ores and minerals associated with these elements. We'll just see the important aspect of this. So the 78% of that in the nature is of, that is nitrogen. The remaining 21% where we get the oxygen. The mainly the nitrogen which is present in the form of NaNO3. Okay, so rest of the things that is given in your NCERT is not that important. So what you have to remember here is this. Now let us study the properties of this group 15 elements. The first one is electronic configuration. So you have already learned how to write the electronic configuration. So the general electronic configuration for this group 15 elements, what it is so the noble gas, okay, noble gas NH2NP3. Remember this is very important. So the noble gas here, for this helium, neon, like that. As we move down, each element will be taking place in that. So NH2NP3, if the element, if it is belonging to the second period, then the N here will be 2. If the element, if it is of the third period, then the N here will be 3. Like that. Okay, so if you know the period, you can write that with the noble gas and then the N. Okay, this is as simple as that. Here the S orbital here is completely filled, whereas P, which can accommodate the 6 electrons, whereas the electronic configuration for this is 3, that is, it is half filled. So because of the presence of this half filled, the electronic configuration is like this, and then as a result what happens, this will give a extra stability for these group 15 elements. Okay, now this is about the electronic configuration. Coming for the second property, that is atomic number. You know, as we move down, there is a considerable increase in the atomic number. You know that is simple property. Coming for the ionization enthalpy. So what else this ionization enthalpy is? Nothing but, see here I have a element whose nucleus is this, and the electrons will be completely revolving around this nucleus. Okay, what I want to do is, I want to remove the one electron from the outermost orbit. Okay, see, you can remove the electron from the innermost also, but for the explanation what I am saying here is, I want to remove the electron from the outermost orbit. So in order to remove the electrons, no, here nucleus is there, electrons will be revolving, some force of attraction will be there. In order to remove that particular electron, how much energy is required? Okay, so how much energy you are spending in order to remove that? That is nothing but the ionization enthalpy. Okay, now if there is a one orbital here and then again another orbital, and consider like this. Okay, you know that the force of attraction from the nucleus to this outermost will be very less. That means it is very far. Distance is too much. Here it is very strong attractive force. Now you can clearly understand that you can remove the electrons from this orbit very easily as compared to the electrons from this. Why is it so? The force of attraction is very much high. So as a result, what happens? If you are removing the first electron, it is called as first ionization enthalpy, and then the second ionization enthalpy, third. Now if they give you the ionization enthalpy values like first, second, third, then can you able to arrange them in the increasing and decreasing order? It is simple, no? So that is why always remember, this is applicable to any elements in the periodic table. The ionization enthalpy first is less when compared to second and then compared to third. This is a very important part of this. Now you have to remember this. Okay, note this. Next one is electronegativity. So electronegativity, that is electronegativity property that decreases down the group. So nitrogen is having the electronegativity more compared to the other. So that is a third property. Coming for the covalent and the ionic radius. Okay, so no need to remember the value as they have given it in your NCERT book. They have given it as a chart. You just have to know how that varies. Okay, down the group. Here you can see covalent and ionic radius. As there is a electron, that means atomic number is increasing and electrons are being added to the new shell. Obviously the distance will be increasing, that is covalent and ionic radius increases down the group. Okay, that is about the covalent and the ionic radius. Coming for the two important properties, that is boiling point and the melting point. Here what you have to know is, you already learnt that the boiling point in the organic chapters. Okay, you have learned that the boiling point, on what factor it depends is, boiling point is directly proportional to what? Molecular mass. As the mass increases, then the boiling point will be increasing. So the boiling point increases from top to bottom. That means this is having more boiling point than this, like that, because the masses are increasing here. The next property is that as melting point. So the melting point, there is no considerable increase here. So how it varies is, up to arsenic, okay, it is increasing. But after that, what happens here is, the value go on decrease. Okay, so this is one thing that you have to remember is, it is here the d orbitals are involving as we move. That is one thing, and then the inert pair effect also considered here. That is why this is the trend here. Okay, yes. The next thing is, that is physical properties. You can see the physical properties here. The nitrogen atoms and the phosphorus, all these, they are present as a polyatomic. What is this polyatomic? Means two atoms, like more than, for example, N and N2 will be formed like that. They are called as polyatomic, and then all of them are solid in nature, except what? Except dinitrogen. So dinitrogen is a diatomic gas. Rest of them are, they are solid in nature. Next, the electropic form, that is, what is allotropy is nothing but, for example, carbon exists as a different forms like diamond, like graphite. Okay, so except nitrogen, all other shows a allotropic. Very important. Okay, for your entrance examination, they may give you the 4 option. Out of this, which one will not have the allotropes? Okay, you should remember that except nitrogen, all of them have a allotrope. Okay, now this is all about the general trend, general physical properties. Now let us study about the chemical properties of these. The first chemical property, that is oxidation state. Okay, you know that the various elements show various kinds of the oxidation state. So mainly the oxidation is taking place because of the presence of the valence electrons in it. Okay. Now the common oxidation state for the group 15 element is -3, +3 and then the +5. Now let us see the trends in this. Very important. So the same way you learn this and the same way as it is how the NCERT has explained, the same way I am explaining here. So no need to read any extra other things. Now the -3 and +5 oxidation states for the elements, what happens is the oxidation state of these decreases down the group. That means, for example, if they give you like this, nitrogen which is having +3, phosphorus which is having +3. Out of this, if they ask you which one is more stable, you should know that this is more stable. What is the reason for this is, there is a trend here. So the -3 and the +5 oxidation state decreases down the group. Why? Due to the increase in the size, and also there is a metallic character. Now the question arises to you, how is the metallic character is influencing to the oxidation state? Now simple, I have explained you here, the metallic characteristic increases down the group. Okay. Now when do you call any element to be as a metal is, metals are those which will give the electrons very easily. That means they are electropositive in nature. If they are giving the electrons, that means they are undergoing oxidation state. Yes, they are showing the oxidation number there. So that is why there is a decrease down the group. As a result, what happens here is the -3 and the +5 oxidation state, no, there is a considerable decrease here. Okay, it is, you can explain that with the size as well as the metallic character, any one. Okay, this is about what? -3 and the +5. I have told you decreases. That means what happens here is bismuth with the +3 or the -3 or the +5 will be very unstable. Okay. Now, so that is why bismuth, it hardly forms any compound with the oxidation state as -3. Now, so the only compound of bismuth with the with the 5 with the 5 oxidation state, that is BiFi. So you have to remember this. This is only, there is no other compounds that are present. This is about what? -3 +5. It decreases down the group. Now, coming for the +3 oxidation state. +3 oxidation state increases because of the inert pair effect. So in the first part of this, I have explained you what is inert pair effect. Okay. Now you can see the +3 oxidation state. Why it is? Because here NS2 is there and then NP3 is there. Due to the inert effect, the s orbital electrons are inactive. That means they are not taking part in the chemical form. Only the p orbitals will be taking. So how many electrons are there here? 3. So that is why the +3 oxidation state increases because of the inert pair. Okay, this is very important. Now, in the question you have to be very careful what oxidation state they have asked you there. Next, the nitrogen element which shows all the oxidation state like +1, +2, +4, whereas phosphorus which shows +1 and the +4 oxidation state. So remember, -3 +5 decreases down the group, +3 increases down the group. The common oxidation state is -3 +3 +5, whereas the nitrogen shows +1, +2, +4 as well. Phosphorus will show +1 and +4. Next, nitrogen, all the oxidation states, like from where? From the oxidation state number from +1 to +4, nitrogen is showing now. That tends to disproportionate in the acid gradient. It is very important point. For example, I have written a reaction here where HNO2 is converting into HNO3, water and NO. So what does this sentence that I have written mean here is, if the nitrogen is having an oxidation state between what? +1 to +4, then in the reaction, that is in the chemical reaction, if a reaction is undergoing the oxidation state from +1 to +4, it is understood that the reaction is disproportionate reaction. So what does it mean is, disproportionation reaction is a chemical reaction where a given same compound will it will be forming a oxidation as well as a reduction. Example, you can see. You know that how to identify the oxidation state for the unknown element. Here the nitrogen, you have to take it as X, hydrogen +1, oxygen -2. Okay, so +1, this we do not know, so X -4, 2 for this. So X -3 is equal to 0, X is equal to +3. Similarly, you can remove the oxidation number for the other. So here +3. For this it is +5, for this it is +2. From +3 oxidation state, here it is +5. So increase in the oxidation number is called as what? Oxidation. Here from +3 to +2, there is a decrease in the oxidation number, so this is reduction. So in the reaction, if both oxidation and reduction taking place, there is a disproportionation taking place. So that we are going to call it as a disproportionation. In acid medium, it is nothing but we are going to use a H+ condition there. Okay, this is about the nitrogen. Next, one more thing that you have to remember here is group 15 elements. We know that the 5 valence electrons will be there, NH2, NP3, that means 5. So it has to show the 5 bonds, that is 5 covalent bond has to be formed by this. Okay, all other elements will show except what? Except nitrogen. It is very important. So the nitrogen forms only 4 covalent bond. So what is the reason why it is only forming 4 covalent bond is, remember here, as we move down from this group, no, here this this other elements of this, no, bismuth and this Sb, there is a involvement of the d orbitals there. So as a result, what happens? No, they can form a bonds more than 4 or the more than 5 because of the involvement of the d orbitals there. So there is a possibility of forming a higher compounds there. Whereas for the nitrogen, only the p orbital, so that is why it shows only 4. The phosphorus, you can see there is a compound that is PF6. See, you can see there is more than 4 covalent bond. So involvement of this d orbitals, no, they make them to form a more compound. So this is all about the some of the physical properties and then some chemical properties of this group of 15 elements.